Okay, hi all. This last video is going to be the finishing up of chapter 6. So I wanted to get that out for you as soon as possible. So let's go ahead and jump over to OneNote. Okay, there are two main kinds of formula you're going to run into. One is called an empirical formula, and the other is called a molecular formula. Now, it's important to be able to distinguish between the two. The empirical formula is the simplest form of a compound. It says what elements are present. And it gives you the ratio of the elements. And that also means it's the mole ratio as well. Okay, so to find the empirical formula, basically what we do is we, many times you'll either get, when you're trying to find the identity of a compound, you'll get either actual mass numbers of what's present, or you'll get percentages. And frequently you'll get percentages more than you'll get actual mass numbers. Okay, but we're going to do both kinds of problems here to give you an idea of how to do this. Okay, so again, this is the key to working empirical formulas. We're looking for a simple mole ratio. Simple mole ratio. Now that simple mole ratio means we have to first calculate the moles of each, and then we're going to find a simple ratio. Okay, so step number one is to convert the grams, if we're starting with grams, into moles. Now with the percentage problem, we're just going to assume we have 100 grams, so the percent automatically convert to grams, and I'll show you that in a minute. Either way, we're going from grams to moles. Okay, so step number one, convert grams and or percent to moles. Okay. Next step is to get the ratio. And that ratio is going to be the smallest ratio, and I'll show you how to do that in a minute. Okay. All right, and then these will then convert to subscripts. Okay, so step number one is grams to moles. Okay, we're working with phosphorus and fluorine, so that's P and F. Okay, so phosphorus is 3097, fluorine is 19 even. Okay, so it's going to be 3097 and this is going to be for the phosphorus. Fluorine is going to be these are from the periodic table. This is just the molar mass. Okay. So let's do that. 161 divided by 3097 is now this is 3 sig figs. And this is 4 over here. Okay, so this is step 1. Step 2 is we're doing expressing the ratio as the smallest possible integer. Okay, that means we're going to divide by the small, large divided by the small. Okay, so that means you're going to take 0.57 divided by 0.520. Okay, and that's going to give us okay. We are going to round to the nearest integer, except for one exception. And I'll talk about that later. Okay, so that's basically 3. So the mole ratio, now this is the F, this is the P. So the ratio of F to P is 3 to 1. Three to 1. And we don't have to write the 1, so it's PF3. Okay, 3 basic steps. Convert to moles, get the mole ratio, divide it out, and then convert to integer. And that becomes the subscripts. Okay, so we have iron, oxygen. We want to find the formula, the empirical formula. Again, because we're doing this here, this is the empirical. Now, sometimes it is also the molecular formula. Sometimes. Okay, so let's go back to this guy here and go and work this out. And molar mass Okay, we have iron and oxygen. Iron is 5585. Oxygen is 16. So again, step number one is calculate moles. So we're looking at okay, we divide the big by the small. So that's step one. So it's 5 to 1. So that means we have 1, oxygen is 5, or that. Now, frequently you're given percents. And remember, percents always total 100. So if they only give you part of the percents, you subtract from 100 to get the remainder. For example, say we only had the 2.2 and the 77.8, and they said the remainder is carbon. Well, you then subtract the 2.2 and 77.8 is 80%. 100 minus 80 is 20. That's how you find the remaining one. And then it'll say the remainder is blah, blah, blah. Okay. All right. So we have carbon, 20%. Hydrogen, chlorine. Now you can assume any gram amount you want. I'm going to assume we start with 100 grams. I highly recommend that. You can start with anything you want, though. The math is significant and easy. If you start with 100 grams, that automatically converts the percent to grams. So that means that's 20 grams, 2.2 grams, and 77.8 grams. So 20 grams. And we are going to assume this is 20.0. Keep everything with 3 sig figs. Okay, spin carbon is 12.1 grams. And we're going to assume this is 3 sig figs as well. Doesn't have to be, I'm just saying that you'll get better precision that way. And hydrogen is 101. And then chlorine It's 35.45, I believe. Yes, it is. Okay, so we're going to divide. That would be step 1. And 1.67 is the smaller of the 3. So we're going to be dividing that into 218 and 219, which are basically the same. And that's 1.3. Now, the rules I just mentioned to you, we would take and round that to 1. Okay, if, we're not going to do that though, if it's 0.3, if it's 0.5, okay. So what this means is I'm going to multiply everything by 3. So if we were going to write this out, it would be 1.3 HCl. We can't have fractions, so we're going to multiply everything by 3. Okay, so 3 times 1.3 is 3.9, or 4. 1 by 3 is 3. Okay, and if it was around 0.5, we would write it out like this, only we would then clear the fractions in the subscript by multiplying by 2. Okay, so this is the empirical formula. So remember, keep that in mind. All right. Now, the empirical formula is the simplest ratio. The molecular formula is the actual formula. And they can be one and the same. So what you do is if it says this is the empirical formula, and this is the molar. So that's the molar mass of the actual molecule. Okay, so this is the empirical formula. This is the actual molar mass. So the first thing we need to do is determine the molar mass of the empirical formula. Okay, all we're doing there is just it's from the periodic table, 2906. Then you divide how many of those 2906s are there in the actual molar mass? In this case, 2 of them. So that means we multiply everything by 2. So we end up with C4H10. Okay, so let's look at another problem here. Fructose is a sugar found in honey and fruits. And fructose is also found in high fructose corn syrup, which is extremely bad for you. It causes many, many problems associated with metabolic symptoms. We need to keep that in mind. Minimize fructose. I'm an organic and biochemist. Trust me, fructose is not good for you. And if you take my nursing class, if I ever teach it at Sac City, on the organic and biochemistry side, I'll talk in length about why that's bad for you. Okay, all right, so we have, this is going to be a problem from start to finish. Okay, so we analyze fructose and we end up with 40% carbon, 671 hydrogen, and the remainder is oxygen. Okay, that means we have to, this is going to be 100% minus 40 and 671. So basically 100% minus 100 minus the sum of those two. Okay, so we're looking at 100 minus okay, so that's 53.29%. Okay, I'm going to assume 100 grams. So I mean that is automatically 40 grams, 671 grams, 53.29 grams. So step 1 is to convert to moles. Find the empirical formula, and then because we're given the molar mass of the entire molecule, we're going to then divide the empirical formula into the actual molar mass of fructose and see what that ratios end up being. Okay, so we're going to take, I should have given myself more room here. Let me try to do this here. Give myself more room. All right, so I'm going to have 40 grams times 1 mole, 12.1 grams. 5329 times 16 grams for the molar mass of oxygen. And then okay, so let's see what these numbers come out to be. This is okay, so that's step number one. Step number two is we divide the large by the small, and we notice that the carbon and oxygen are both 3.33 moles. We're going to take and this is under the 199. Okay, or 2. So we're going to 2, 1, 1. Okay, so that means it's carbon, oxygen, hydrogen. Okay, now that's the empirical formula. Okay, now we were given the molar mass of the whole thing up here at 180.16. So now we're going to divide the empirical formula molar mass into the molar mass of the whole thing and see what ratio we get. Okay, so what is the molar mass of the empirical formula? Okay, that's going to be molar 1, 16, 101. So that's what, 29.02, right? The molar mass of the empirical formula is 2902 grams per mole. Up here it says we have 180.16. And that is the molar mass. And we're going to divide that by the empirical formula molar mass. This is the molecular molar mass. So we're going to divide that by 29.02 grams per mole. Notice our units are canceling because all we want is a simple ratio with no units. So that means all units have to cancel. So this is the empirical molar mass. Okay, and what is that? Okay. This ends up being 6.2. Okay, or 6. So that means we are going to multiply everything, excuse me, in the empirical formula subscript wise by 6. We have C1, O1, H2, all by 6. So that's C6, O6, H12, which is the official ratio of most simple sugars in our biological system. That's called a hexose, hex meaning 6. All right. So that concludes chapter 6. A lot of math in chapter 6. Chapter 7 has very little math. So we have a nice balance between the two. These items in chapter 6 need to be thoroughly understood, so you will not get lost in unit 5. Unit 5 is very mathy, using a lot of these same numerical steps.